Japan built a wall so massive, most people on Earth have never heard of it.
It is taller than a 4-story building. It runs 400 kilometers. It cost $12 billion. 400 kilometers? New York to Boston and back twice. Every inch of it built by hand. That was 2011. This is today.
The wall exists because of what happened on the left. Wait, this wall is now so high.
My husband ran toward the sea. I never saw him again.
Every meter of this wall was paid for in grief. Now watch what they actually built. But engineers warned, if this wall fails, it could make the next tsunami far deadlier. March 11th, 2011. The ocean floor moved 50 meters in 3 minutes. What came next was unstoppable. That rupture displaced 500 cubic kilometers of ocean. The wave crossed Japan in 30 minutes. Not a wave, a moving wall of black water. 90% of Japan's seawalls failed in that single hour. Every engineer in Japan took notice. What came next was unstoppable. That rupture displaced 500 cubic kilometers of ocean.
It did not break from the front. Water topped it, eroded the back face, foundation vanished.
That is the engineering problem. One mayor, one wall, 3,000 people alive. That village gave Japan its blueprint. Build it taller. Now you might be thinking, how do you design a wall to stop an entire ocean? Here is the brutal truth. This wall was never designed to stop the 2011 scale wave. Here's the crazy part. Most of this wall is underground. Only 14 meters shows. Engineers modeled this wall.
Wall height changes every kilometer. Taller on exposed headlands, lower in sheltered bays.
440 separate teams. If even one goes bankrupt mid-build, a gap opens. Zero tolerance. Before one stone is placed, survey ships drill the seabed.
3 foundation types: soft clay, dense sand, hard rock. Each requires completely different engineering.
First task: demolish the walls that failed. Study every failure mode. Then build the new one bigger. 400 kilometers, measured meter by meter. They cleared an entire coastal pine forest. Erosion matting follows the bulldozer.
The tide gave them 4 hours daily on the seabed. Every single minute was counted.
The clay zones cannot even support a bulldozer. The ground is dangerously soft down there. Steel road plates spread the load. The machine floats above the mud. Simple, effective. They are building the foundation 25 meters below sea level, in the active surf zone. The clay zones cannot even support a bulldozer. The ground is dangerously soft down there.
Engineers check the underwater progress by sonar. They cannot see it.
Between boulder and fill sits a filter layer. Miss it, the wall slowly bleeds away.
After weeks underwater, the rubble mound breaks the sea surface. Watch what comes next.
A geotextile membrane stops fine soil particles migrating into the rubble. It works silently, forever. An uncompacted mound settles unevenly. A settling foundation tilts the wall.
A 1-to-1 and 5 slope angle exactly. Steeper and boulders slide.
A platform is rising inside the ocean, from nothing. Now the real wall construction begins. Sheet piles driven 10 meters into the ocean floor, just to protect the wall toe.
Z-profile interlocks. That connection transfers shear forces between every pile in the wall. That steel wall fights the retreating wave, not the arriving one. Backwash scour destroys foundations.
One buried boulder deflects a 12-meter pile sideways. The entire alignment is now compromised. Pre-drill the boulder first, crush it. Then the pile drives straight through the cleared hole.
The wave going back out is more dangerous than arriving. Backwash vacuum pulls the foundation sand out.
30 dump trucks running 16-hour shifts non-stop. One breakdown stalls the whole cycle.
300-millimeter lifts, no more, no less. Geotextile reinforcement layers inside every seawall body. 98% proctor density, or the inspector shuts the job down. Every single layer tested.
Press your foot on 98% proctor fill, nothing moves. At 85%, it sinks.
300 millimeters per day. 18 months until the first tsunami season with the wall standing.